For the last several months, we have been talking and trying to get more information about this rare interstellar comet we've now come to know as 3I Atlas. And we've pulled in Harvard astronomer Avi Loeb many times, but today he's released 2 new papers about 3I Atlas, and he's joining us now to talk more about what he found, what's new. Thanks for your time once again.
It's a great pleasure to join you.
All right, what's in the new papers?
Yeah, so the most exciting development is that in about a week, on January 22nd, the Earth will be between 3I Atlas and the Sun. And that is to a precision of 0.69 degrees, a very precise alignment that we are very fortunate to have. It's sort of like having a guest and then realizing how fortunate you are in terms of the circumstances. Now, what would that allow us? Because we would be just between the sun and this object, we will see the reflection of sunlight from the object and from any dust or gas around it, from the direction of the sun. And that means that we should expect a brightening of the object on the 22nd of January, because usually when you look at dust from the direction of the sun, you can get an enhancement in the reflected light, because first of all, if you imagine a particle being illuminated by light, when you look at it from the direction of the sun, you're seeing it in full. You're seeing the full face of it, just like when we see a full moon. But in addition to that, there is a quantum mechanical effect that enhances backscattered light. In other words, the light that is impinging on any particle is reflected with constructive interference. So you end up getting a larger signal, larger brightness, because you're looking at it exactly from the direction of the sun. And therefore, we can learn about the nature of the material that is being shed by 3I Atlas much better than before. We could infer the characteristic structure of the dust particles coming from it, whether they are small or big. And by the way, in order for them to reach such great distances at which we see them in the anti-tail, there is this jet pointed towards the sun. They must have a large size, at least 100 times more than we are used to in terms of dust particles. They need to be pretty big, about 10 to 100 micrometers, just because big particles have less surface for their mass, so they cannot be pushed as easily by reflecting sunlight. And we don't see a tail behind this object away from the sun, presumably because the particles that are shed by the nucleus of this object 3I Atlas are big. And this observation on the 22nd of January will allow us to infer the nature of the particles that are being shed. And moreover, there is a very unusual, anomalous polarization of the light that was detected from 3I Atlas several months ago. So we should be able to learn much more about the nature, the origin of this unusual polarization. So all in all, we will be able to figure out some of the anomalies of 3I Atlas on the 22nd of January. And we should not take it for granted, because it may be decades before we have another object that is aligned so perfectly with the Earth-Sun axis. That's one paper from today. But then the second one I should mention is based on data from the Hubble Space Telescope that was taken. There were a large number, 17 images taken between November 30th and December 27th by the Hubble Space Telescope, and they were shared publicly, and we were able to analyze them and notice that the jet coming from the object, that there are 2 jets. There is a prominent one towards the sun and a smaller one away from the sun, and this jet structure seems to wobble over 7.2 hours. Basically wobbles around the rotation axis of the object, just like the light beam from when you look at the lighthouse, as it rotates, as it spins, the light beam is moving along a cone. And in the same way, the jets that are presumably launched from near the pole of the rotation axis, are wobbling in the sky. And we can measure the rotation period of about 7.2 or 7.1 hours. And we also measure the same rotation period from the brightness variations of the object. So when the jets are moving around, the brightness of the object changes. And we notice exactly the same period. So this is a second paper where the brightness we monitored from a telescope on Earth. So the Hubble Space Telescope data and ground-based data seem to agree on the rotation period after perihelion, after the object passed near the sun. This is the first report on the rotation of 3I Atlas.
I'm looking over a couple of your reports, at least one of the reports that immediately comes up about this topic online from your papers that you published today. Explain a little bit more of this concept of the opposition surge.
Right. So that's when the object appears exactly opposite to the sun relative to us. We are the observer, and we look at the object, and it happens to be exactly on the opposite side from where the sun is, which is very good for observations, by the way, because the sun is not visible at night, and you just look at night in the direction of the object, you see the reflection of sunlight from it. And because of that, there should be a surge in the brightness of the object. As I explained before, it's just like a full moon situation, also amplified by some quantum mechanical effect of backscatter of the sunlight. So altogether, it's a great opportunity that was not recognized. And the reason I wrote this paper was to encourage observers to use that opportunity and use the best telescopes we have to measure the properties of the dust and gas around the object that scatters sunlight. And I wrote it with a collaborator named Mauro Barbieri from Italy.
And another thing that you have in here, an unprecedented polarization properties. Explain that a little bit more.
So light is polarized, as we know. For example, when during a sunny day, you often see reflection from an asphalt road because what happens, that reflected light is getting polarized. And when you wear sunglasses, very often you block some polarization of sunlight. Light can be polarized, meaning the electric and magnetic field of the light can move differently around as the light propagates. For example, circular polarization is when the electric or magnetic field are rotating clockwise or counterclockwise as the wave propagates. And you can have two modes of polarization. If you combine circular polarizations in opposite directions, you can get linear polarization. And so light can be polarized. And what was found about this object is that the polarization is negative and very extreme, unprecedented among comets. And I suspect that it's a result of this very prominent jet that is aimed towards the sun, because that is we have never seen such a thing, propagating to about 400,000 kilometers, which is comparable to the Earth-Moon separation. So just imagine a jet coming from Earth, going all the way to the Moon, 10 times longer than it is wide. That's what happens near 3I Atlas.
Any idea as to why we're seeing these unprecedented or, these things we haven't seen before?
Well, that's the puzzle. That's what makes science fun. And I wrote 3 papers already on this anti-tail jet, trying to explain it. And it's still unresolved. One possibility is that it's made of fragments of ice, and they do get evaporated by sunlight eventually, and they never turn around to become a cometary tail. Another possibility is that we're dealing with large dust particles or objects ejected by 3I Atlas, and they don't suffer much slowdown as they go against the solar wind and against the solar radiation. So we don't know the actual explanation. It would be very informative to get new data on January 22nd, and my hope is that observers will listen to me and look at this object then.
Okay, so when do people need to be out on January 22nd? Give us our marching orders for January 22nd.
Well, we need the large telescopes to get high precision data. We need the telescopes that are bigger than 1 meter, roughly half the height of a person. And only those bigger telescopes could get us high quality data that would inform us about these jets. But amateur astronomer telescopes that are a factor of a few smaller are also very useful because we can see the anti-tail. We've seen it for a couple of months when no data from large telescopes was available. So I very much value the information that the amateur astronomers collect, and it definitely was featured in my essays.
Give me your thoughts on NASA's Artemis 2, this moon mission for 2026.
Yeah, so that's exciting. The astronauts will, for the first time, since the Apollo program, we will have humans coming close to the moon, except they will not land on it in the first mission, Artemis 2. They will just circle around the moon and come back, and that's a good first step. And my hope is that by 2030, indeed, as NASA aims to do, we will land humans on the moon, but not only for the sake of demonstrating we can do it, but more importantly, to establish some sustainable base there. And that is important for national security, for national pride, but also for scientific applications. The moon is very beneficial for astronomical observatories, for example. It has no atmosphere, so there is no turbulence in the atmosphere that sort of causes scintillation or fuzziness of sources of light in the universe. And there is no light pollution as of yet from cities on the moon. So it's a wonderful environment to put telescopes. But in addition, the moon doesn't have any seismic activity. So, for example, a decade ago, I wrote a paper arguing that we should put probably a gravitational wave detector on the moon, like LIGO that we have in the US right now. And the advantage of the moon is because there is no seismic noise that one can go to, in principle, lower frequencies of gravitational waves and detect black holes all the way to the edge of the universe. So the moon offers great advantages for astronomical observatories as long as the cities that we build there will not be too populated.
What are the first things you're hoping to gain from their trips?
Just demonstrating we can do it and bringing people back to the moon, that would be extremely valuable. You know, the moon is a museum that we haven't really explored because over the past 4.6 billion years or so, it was able to collect materials on its surface without burning them in the atmosphere. The Earth burns objects that are smaller than about a meter as they collide with the atmosphere and as a result of the friction with air. And the moon just collects them on the surface. And so there should be a treasure of impacts over there that could inform us about the history of the solar system, including technological artifacts from other civilizations that by chance collided on the surface of the moon. We just are not aware of them because we haven't explored that museum as of yet. And they could be covered with dust, but we could potentially survey the surface of the moon and find more about it. You know, it's a fascinating environment. The same is true about Mars. It's also a museum. It has a very thin layer, atmospheric layer. It lost its atmosphere 2.5 billion years ago. So for half of its history, it was without an atmosphere. And we know that Mars had liquid water on the surface. So that adds another interesting part to the scientific study of it. We want to figure out if it had life even before Earth had it.
Let me ask you this. You kind of casually mentioned other civilizations that may have been out there. Do you think that when we do send these astronauts to the moon, that we'll actually get all of the information they collect?
Well, if they engage in the search, you know, it's just like people who are lonely. They often complain about the fact that they don't have a partner. They often say what Enrico Fermi said in 1950, where is everybody? And just last week, we heard a report from the SETI community, from the Breakthrough Listen project, that was searching for radio signals from 3I Atlas, the interstellar object we talked about. And they just searched for 5 hours. And this object spent 8,000 years in the solar system, from the edge of the Oort cloud until it got close to the sun. 8,000 years. And just thinking that if you survey it for 5 hours, you will learn whether it's technological or not, it's very presumptuous. And it's not clear that there would be a transmission in our direction. It may be beamed in a completely different direction. It may not be in the frequency range that we search for, but it may not be in the time window that we search for. And moreover, an interstellar traveler will not correspond with its senders, because there is no benefit to that. It takes 30,000 years for light to cross the Milky Way galaxy to get to another star far away. And so there is no point in exchanging information in real time. What would make sense is, after completing the journey through the solar system, to relay all the relevant information in a burst of radio waves, maybe, but not every 5 hours, the way that these SETI people imagined. It's just like sending a kid out of home. You don't expect the kid to be in constant contact with you. The kid has its own brain and makes decision on their own, and they send a post or a tweet every now and then, or some a message. But imagining that we can rule out the technological origin just based on our most primitive technologies that we invented back 100 years ago is really inappropriate. We should be more humble. I do believe that it's very likely that we have neighbors. And of course, it doesn't really matter whether we appreciate that or not, whether we dismiss that, whether we search for that. It's completely irrelevant. They are either out there or not. And it's very likely that they are out there, because there are 100 billion stars. 10% of them have a planet the size of the Earth, roughly at the same separation from a sun-like star. And most of the sun-like stars formed billions of years before the sun. So there was plenty of time for them to be much more advanced than we are and to reach our backyard. And the most important reason for us to search for them proactively is because it can help us be better. Because those successful civilizations that managed to reach us are far more accomplished, and they would serve as a role model for us. So it's for our benefit to be agnostic and not dismiss the idea, not to argue that we must be the smartest and not search for anything else, because that would resemble, as I mentioned at the beginning, a person who wants to date, to find a partner, but then argues, oh, there is nobody good enough for me. and when you go on dates, you better aim high. That's my recommendation, not aim low. What the astronomy community is doing right now is aiming low, because it's searching for microbes. The astronomy community wants to invest more than $10 billion in the next 2 decades to search for microbes. And I say, in the search for a partner, we better aim high. We better look for an intelligent species out there, because we can learn from it. Just imagine sitting on a dinner table when the partner is a microbe. I mean, okay, well, it's good to know that you're out there, but I cannot learn much from you.
Professor Loeb. Oh my goodness. Astronomy and dating advice. We didn't know there was a correlation here, but you're drawing the connection. We're following where you're going with this. And since we're talking about dating, sometimes you look far out and you think they've got to be way maybe out there somewhere, and maybe the person is right under your nose. Do you think that we're missing something that's a little closer in from the moon and Mars?
Yeah, it's quite possible, because we've been searching for 65 years for radio signals out of planets very far away, but maybe there is something next to us that is using much more advanced technologies that we cannot really figure out. For us, it looks like it's not out there, but it's just because we are still in the Stone Age. And just imagine a cave dweller finding a cell phone they would argue that it's a rock of a type that they've never seen before, but they would still insist that it's a rock because it's shiny and it's solid. And we might be treating objects that are potentially much more advanced than we can imagine as if they are natural. That's quite possible. And the communication may not be with radio waves. It may be with some other devices that we've never imagined because our imagination is limited by our experience. I always recommend not relying on Hollywood script writers when you imagine extraterrestrial intelligence. And you know, we know about the unknown, some unknowns. For example, most of the matter in the universe, we call it dark matter. Most of the energy is dark energy. We don't know if there are entities just like us out there. So these are the known unknowns. But the most exciting discoveries will come from the unknown unknowns. And it could well be that we are surrounded by things that we don't recognize, you know, but just because we have a very limited imagination experience that is based on the training data set that we have. You know, we are just like AI systems. We are limited by our training data set. And if we were not trained on something beyond our own technologies, we might not recognize it.
Very interesting stuff here. Okay, so you've given us our homework for January 22nd. Since we are in January, are there some other notable dates or time frames that you're looking at for 2026?
Yes, March 16th. That's when 3i Atlas will come closest to Jupiter, within exactly the distance where Jupiter's gravity dominates over the sun's gravity. And it could well be a coincidence. Once again, this object seems to have a lot of coincidences. It lies within 5 degrees in the ecliptic plane of the planets around the sun. It also appears to be to come very close to Mars and Jupiter, and it has a rotation axis which is aligned with the direction of the sun at large distances to within 10 to 20 degrees. All of these are geometric coincidences that we cannot explain. People would argue it's just a matter of chance, but each of them has a percent level chance, and when you put them together, it's very unlikely. But anyway, so there will be this approach to Jupiter at exactly this hill radius where Jupiter's gravity dominates, and one possibility is that it's planned and that the object will deploy some devices that will become satellites of Jupiter. And we can obviously monitor what happens near Jupiter. We have the Juno spacecraft there, and we have 2 other spacecraft on their way to Jupiter. One is JUICE, and the other one is the Europa Clipper. Both were launched by the European Space Agency. So altogether, we'll keep monitoring Jupiter in the years to come. And if we see satellites that were not there a while ago, that appeared suddenly after the passage of 3i Atlas, then of course it would raise the suspicion that it might be technological, because there is no reason for it to release or deploy fragments that will become gravitational bound to Jupiter if it's natural. In order for a daughter object to be released and stay bound to Jupiter, it needs to lose the velocity of 3i Atlas away from the sun and have just the right amount of slowdown to become bound to Jupiter. So that is nearly impossible for a natural object to do. And if we see anything new there, we will know that we were dealing with something like a Trojan horse, something that we thought is natural, but maybe not. And of course, that was the original alert that I brought about the potential technological origin of 3i Atlas, like a black swan event. And by the way, there was an interesting reply from the CIA, the Central Intelligence Agency, to a FOIA request for any records related to 3i Atlas. And the reply was not, we don't have any such records. It was, we cannot confirm nor deny the existence of such records. And that is interesting, because there must have been some discussions there. And the question is why? And I suspect it's because they wanted to be sure that it's not a black swan event. Now the intelligence agencies are quite alert to low probability events that have large impact on society. So they probably analyzed the data, wanted to figure out what 3i Atlas is for themselves, and they don't want to disclose it to the public in order not to create any panic as long as they are sure that it's not a risk to the safety of humanity, so to speak, they just put it under wraps and do not release the records. But it's interesting that they did not deny the existence of these records.
Yeah, usually when someone says, I will neither confirm nor deny, that's like, just mind your business. Okay, so we know that January 22nd is our time frame for this month. You told us March 16th will be another time frame. We'll be calling you back about that. You've given me a renewed interest in this conversation to go read Men Are From Mars, Women Are From Venus, ironically enough. So maybe we'll have to call you back around Valentine's as well.
Well, there is much more in common among men and women than between us and extraterrestrials. That's my argument. So, it's a good, sandbox to engage in dating, just to figure out how much more extreme it would be for us to encounter extraterrestrials. Just because they don't necessarily share our biology, they don't share our language, they don't share our understanding of the universe. In fact, they may have a much better understanding. So there would be a lot of obstacles for us to sort of get into an emotional connection with them. But it would be a thrilling experience. And frankly, if I was offered a one-way trip on a spacecraft that would land on the front lawn of my home, I would take it.
That's a good way to end the conversation right there. Thank you so much, Professor Loeb. We always love having you here. We never know where the discussion will go, but one thing is for sure, it is always interesting.
Thank you for having me. It's a great
Take care. We'll talk to you again soon.
Thanks for watching Fox 32 Chicago. Subscribe now for the stories that matter and never miss what's next.